Hey guys, so today we're going to talk about exponent rules and how we can use them to solve and simplify expressions. So before we start, I want to review what each of these are. So when you're looking at this as x to the y, so just remember that x is your base and the y represents your exponent. And in a problem like this, that exponent would be telling you how many times you multiply that base times itself. So I'm going to give you guys a couple of quick examples just to do with this to make sure you guys understand your base and your exponent. Okay, so for this example, I have 1/2 to the third. So basically that's saying that that third power or that exponent is telling you have to multiply 1/2 times itself 3 times. So if you want to, you can actually write it out that way, and you can do 1/2 times 1/2 times 1/2. And then that shows that that is 1/2 to the third power. And then you would actually multiply that out. And 1 times 1 times 1 is just 1. And 2 times 2 is 4 times 2 is 8. So that's how you would solve that one. Now I want to give you one more example with negatives before we move on to the actual properties that we're going to talk about today. So I want to talk about these ones with negatives really quick because they are different and I want to show you why, so that you don't make any mistakes when we do start using properties. So the first one is -2 in parentheses to the 4th power. The next one is -2 to the 4th. So this first one is saying that this whole thing is to the 4th power. So that means it's basically saying -2 times -2 times -2 times -2. Okay, so basically it's saying that the whole thing in the parentheses is times itself 4 times. So negative times a negative is a positive, times a negative is a negative, times a negative is a positive. So this answer would be a positive 16, okay? Now this next one though is saying it's -2 to the 4th power. So that's saying it's negative times 2 to the 4th power. So this one is more like negative and then 2 times 2 times 2 times 2. So again, all of this on the inside of the parentheses is 16, but there's a negative on the outside, so your answer for this one would be -16. So they are different and parentheses matter. So make sure you guys understand that. Pause it if you need to, and then I'm going to start talking about the different properties. Okay, so the first one we're going to talk about is the product of a power, and what this is when they have the same base, you're just going to add the exponent. So I put that for you, and then I'm going to give you guys an example. So I have 4 to the 2nd times 4 to the 3rd. So like you said, the same base, you're going to keep your base, so it's just a 4, and then you take 2 and you take 3, and you just add them together, so that's going to be 4 to the 7th. Because that's a really big number, I'm not going to ask you to solve it, so you would just simplify it, so that would be your final answer, and it would just be 4 to the 7th power. So the next one we're going to talk about is power of a power, and with this one, we're actually going to be multiplying the exponents. So let me write that down for you, and then we're going to do an example. So for this example, I'm going to have 4 to the 6th to the 3rd. So what we're doing is we're keeping our base, we're keeping our 4, and then you're taking 6 and you're just multiplying it by 3, so you're multiplying the exponents. So 6 times 3 is 18, and that's your answer. Again, I'm just having you simplify, not solve, because that answer would be really, really big. All right, the next one is power of a product. And for this one, what you're going to actually do is you're going to assign the power to each of the bases. So you can expect to have a different base on this one. I'm going to kind of write that out, and then I'm going to give you an example. You're basically distributing the base to what's inside the parentheses. So like I said, you're basically distributing. So I'm going to show you an example. I'm going to have 3x to the 5th. So what this means is I'm distributing that 5 to everything inside. So this is actually going to be 3 to the 5th power and then x to the 5th power. I'm just simplifying it. I'm not solving it. I don't know what x is, and I don't want to take 3 to the 5th power because that's a big number. So again, I'm just kind of showing you what this would look like. So you could have different bases, and you're basically assigning that power to each base. And the next one is quotient of powers. This is when we are dividing and we have the same base. And what you're actually going to do with this one is you're going to subtract the exponents. So let me write that out and then give you guys an example. So for this one, I'm going to give you an example. So I'm going to take 4 to the 5th power over 4 to the 3rd power. So we have the same base, so we keep the base, so it's just 4. And then if you take it, you're taking 5 and you are subtracting 3 from it. So 5 minus 3, 2. So your answer would be 4 to the 2nd power. Now this one, if they asked you to solve it, you could easily solve this because 4 to the 2nd power is just saying 4 squared or 4 times 4, which is actually 16. So on problems like that, you can actually solve. That is very different than one of the other ones we did where it was like 4 to the 7th or 4 to the 18th. Those ones you can solve easily without a calculator. So make sure you have these 4 written down, and then I'm going to go over the last 2 with you before I give you some examples to try on your own. So zero exponents, I think, is one of the easiest ones. If you remember it, you're never going to get it wrong. Anything to the 0 is always 1. Unless it's 0, then it is undefined. So this one is really easy to remember. Hopefully you got it. So if I gave you the example 4 to the 0 power, you should know that my answer is 1. When it says unless the base is 0, it's undefined, what that means is I can't have 0 to the 0 power. If I have 0 to 0 power, my answer is undefined. That's the only difference. Otherwise, every other number to the 0 power is just going to give you 1. All right, and then the last one we're going to talk about are negative exponents. So negative exponents can be a little tricky because technically we never want them to be negative. So what we're going to do is we're going to use the reciprocal to make them positive. So let me write that down, and then I'm going to do an example with you guys to make sure that you understand. So when you use the reciprocal, that means that you're basically like flipping it upside down. So if I did my example 4 to the negative 2nd, sorry guys, what that means is I need to take the whole thing and flip it upside down. So if you remember, whole numbers are always over 1. So when you do the reciprocal, that means you're taking the whole thing and you're flipping it over, and that's going to change this guy to a positive. So 4 to the negative 2nd over 1, to make it positive, you flip it and do the reciprocal. So your answer would actually be 1 over 4 to the 2nd. And again, a problem like this, if it asked you to solve it, you really could solve it because 4 times 4 is just 16, so your answer would be 1 over 16. Okay? So make sure you guys have all this written down. If you need to rewind, go back and do that, you can. I'm going to give you guys different examples for you to simplify so that you can get some practice, and then I will go over all the answers to make sure you understand them. Okay, so I have a few practice problems for you guys. I'm just going to do these 3 first right now, go over them, and then I'll do more because I want to make sure you guys understand. So you have 1, 6 to the 2nd times 6 to the 4th. 2, 4x, y, so 4 times x times y, all to the 3rd power. And then your third problem is 5 to the 0 plus 2 to the 3rd. So right now, pause it, try these on your own, and then play again so that I can work them out with you. Okay, so for the first one, we have the same base, we're multiplying. So remember, we're going to keep our base, and then we're just going to add our exponents. So 2 plus 4 is 6. So our answer is just 6 to the 6th. I did not ask you to solve that. I just said simplify this one because I do not want to multiply 6 times itself 6 times. Okay? The next one, what you're doing is you're taking that 3, that's your exponent, and you're applying it to everything inside. So that means you're going to have 4 to the 3rd power, x to the 3rd power, y to the 3rd power. Okay? Now you could technically do 4 to the 3rd power. That's 4 times 4, which is 16, times another 4. But I did not ask you to do that, so you can just leave it right here. I didn't say solve it, just simplify it. That's totally fine. Now the last one, you should be able to solve. Hopefully you did. If not, let's talk about it and why it's so easy to solve. So any number to the 0 is just 1. So 5 to the 0 power is 1. And then 2 to the 3rd power is just saying 2 times 2 times 2. Well, you do your multiplication first. So I have 1 plus 2 times 2 is 4, times 2 is 8. So 1 plus 8 is 9. Okay? So write those down, and then I'm going to give you guys a few more to try just to make sure you guys understand this. Okay, so here are your next 3. They do get a little more difficult, but hopefully you guys understand them from the notes. So you have 6 to the 10th divided by 6 to the 4th. 3 to the negative second. That one I just want you to make positive. And then the last one, yes, there seems to be a lot going on, but you guys can do it. You have a to the 3rd, b to the 6th, c to the 4th, over or divided by a to the 2nd, b to the 8th, c to the 6th, and I want all positive answers. So try these last three really quick, and then I will go over the answers with you. Make sure you pause it, try it on your own first, and then come back for the answers. Okay, so for 6 to the 10th over 6 to the 4th, we're doing our quotient power, right? So you're basically just taking these and subtracting. So 10 minus 4 is just 6, so your answer is 6 to the 6th. Okay, this next one, I said I just want a positive. So remember, 3 to the negative second, any whole number goes over 1. So you want to do the reciprocal or flip it over, and that makes it positive. So that's 1 over 3 to the 2nd. And remember, you can simplify that. 3 to the 2nd is just 3 times 3, which is 9. So that would be your answer. Okay. Now this last one is a little more involved. There are different ways to do this. So let me just show you one way, and hopefully that makes sense. So what I would do is, if you're first learning how to do this, separate them all. So you have a to the 3rd over a to the 2nd times b to the 6th over b to the 8th times c to the 4th over c to the 6th. Now, I split them up because I can't put a with b. A can only go with a, b can only go with b, and c can only go with c. So hopefully this will make it a little bit easier for you guys. Now, I'm going to move my screen really quick just so that you guys can see it a little better. So now I can simplify each one of these, and then I can just put them back together. So the first one, I have a to the 3rd over a to the 2nd. Again, these are all dividing, so we subtract. So you're taking 3 minus 2, so now I just have a to the 1st power. If you want to put it over a 1, just remind yourself it's a fraction, you can. Okay, this next one, you have b to the 6th over b to the 8th. But the problem with that is 6 minus 8 is actually b to the negative 2nd. Now remember, we can't have that. So if I remember right, and I write it over here, b to the negative 2nd over 1, and I want to make it positive, you do the reciprocal and flip it. So this over here would actually be times 1 over b to the 2nd. Okay, hopefully that makes sense. And then the last one is c to the 4th over c to the 6th. Well, guys, same thing. 4 minus 6 is c to the negative 2nd. So remember again, you have whole numbers, they go over 1. To make a negative exponent positive, you do the reciprocal and you flip it. So this one would also be 1 over c to the 2nd. Now, I can put all of this back together again. Sorry, move my screen really quick. If you need to see, pause, go back, hold it right here. You're going to put all this back together. So we are just multiplying. So you have a times 1 is just a. If you want to have that first power there, you can. You don't need to. On the bottom, I have 1 times, well, 1 times anything is itself. And then I have b squared times c squared. So I literally just write b squared times c squared. And that right there is your final answer. Okay? So hopefully this helped you guys a little bit. You got some extra practice. You wrote this down so you know how to do the different properties with your exponents. Again, if you need to, go back, rewatch it, pause, do whatever you need to make sure you guys understand.